Hello and welcome to this presentation on Drive Zero, a case study of modularised and circular deep energy retrofit in Ireland. In this presentation, I'd like to give you a personal introduction and then an overview of the Drive Zero project, an introduction to the Irish demonstrator case, an introduction to circularity in buildings and construction, a focus on circularity assessment in Drive Zero, and then some concluding comments and discussion. So my name is Patrick. I have a background in architectural technology and project management. My master's is in architecture in advanced energy and environmental studies, and my second master's is in research methods in the built environment. I have significant experience in sustainable building design, consultancy, research and education, and I'm currently lecturer researcher in the Dublin School of Architecture, Technical University of Dublin, where I'm a lead lecturer on the Masters in Energy Efficiency Design, and I'm also principal investigator on the Drive Zero Irish demonstrator case. Drive Zero is an EU project funded under Horizon 2020. The project is about driving decarbonisation of the EU building stock by enhancing a consumer-centred and locally based circular renovation process. At the heart of the project are these four aspects: demonstrating deep energy retrofit, using off-site modularised construction on the basis of circularity, and developing user-centric business models. The project is demonstrating these concepts and solutions in 7 demonstration cases across Europe, representing quite a diverse range of housing typologies and stock. The transition from a linear economy to a circular economy is a key aspect of the Drive Zero project. The two main broad strategies that are being used within Drive Zero to promote circularization are firstly urban mining, whereby materials, resources and elements from existing construction sector are being utilized and applied in demonstration cases. And secondly, biobased material application, whereby biomaterials or bioengineered materials are being taken from the biocycle and being utilized in the demonstration case. This second aspect is the core focus of the Irish demonstration case. The project has a number of work packages and stages, and we're currently 1 year into the project with a focus on development of circular solutions for 2-dimensional facade upgrades and 3-dimensional pod extensions. So the team involved in the Irish demonstration case includes Technical University of Dublin, Dublin School of Architecture, who are the academic research partner and principal investigator. Coady Architects are the industry partner and architectural design partners. Vision Built are the modularised manufacturing partner, supplying the circularised 2D facade upgrade and 3D extension components. And Westmeath County Council are the building owner, supplying the demonstration cases. And we are being given support and direction from a national advisory board. The Irish demonstration case is located in County Westmeath on the outskirts of Athlone and is part of a small cluster of houses, 3-bed semi-detached houses that were built in the mid-1970s. The Irish demonstrator case represents a very typical Irish house typology, the 3-bed semi-detached house. They were built in 1975 of masonry cavity wall construction with cut roof and vented attic. The original heating system was range with open fire, and number 7 now has a heat pump installed as its space and hot water system, and number 8 is still operating on the original range. The houses have had various upgrades undertaken by the building owner, Westmeath County Council. The two case dwellings have significant differences in their energy characteristics and energy performance. Number 7, which has the heat pump installed, is a C1, and number 8, which is still based on the original range and also has an attic extension, is rating at E1. Both properties have had the cavity wall pumped. Both properties have had insulation applied in the attic on the plane of the ceiling. They're both uninsulated floors. They both have double glazed air-filled windows, but number 8 are of a lower and poorer thermal performance given their older age. The significant difference in the two properties is in the space heating and domestic hot water, with number 7 being based on heat pump and number 8 being on a low efficiency solid fuel range. Both houses are ventilated by passive means and both have standard lighting. An average rating of the two dwellings is coming in at D1, and based on that, the Drive Zero project is aiming to get a 70% uplift improvement, taking both properties or the average of both properties to A3. The application of modularised solutions will focus on the application of a 2D facade upgrade and a 3-dimensional extension pod, all of which will be pre-manufactured using modularised construction, but adapted to facilitate design for disassembly and biobased specification. This schematic presents an overview of the proposed scope of works for the demonstration project. Firstly, a 2-dimensional modularised circular facade upgrade, including windows and doors, a 3D modularised circular extension, heating systems and water system upgrade for property number 8, renewable energies for both properties, and new ventilation system to both properties with ancillary upgrades and lighting upgrades. So current focus of the project is working with our partners Vision Built to modify and adapt their conventional construction approach to facade cladding retrofit and also circularized specification. So here we see preliminary technical drawings of the 2D facade panel. We have the higher level facade and the ground floor facade panel here. Schematics showing assembly, disassembly sequences and proposals for enhanced specification for bio-based materials. So the overall concept of the modularized facade upgrade is the supply and install of pre-manufactured, complete and finished facade upgrade panels and pre-manufactured 3-dimensional pod extensions. The concept of circularity is central to the Drive Zero project, and here we see the butterfly diagram from the Ellen MacArthur Foundation explaining the concept of circular economy. So here we have resources, and we have the stages of manufacture, supply, use, and then end of life to waste. And in the conventional system, we have high material use and high wastage, but the circularization process is seeking to take materials, components, parts, and elements and reintroduce them as close as possible to the higher parts of the supply chain order to reduce environmental impact and wastage. And it's clearly demonstrating two key cycles: the technical cycle and the biocycle. So within the technical cycle, the greater measures are to supply and reuse compared to recycling, where there will be material loss and degradation and additional material and energy inputs. On the biocycle side, there are a number of cycle options. One is an equivalent to the technical cycle where materials and elements re-enter the supply chain, but also there's the possibility for extraction of resources and energy, and that materials that are biological can re-enter normal breakdown within the biosphere and re-emerge as other materials within the cycle and thus re-enter the system. So Drive Zero is examining the application of those concepts specifically within the construction sector. So here we see a linear and circularization flow path more specific to construction. So we have extraction of natural resources being processed into materials, materials being formed into components and parts, and then assembled into elements and buildings. And then we have a building use phase and a decommissioning or disassembly rather than a demolition phase, and waste. So the concept of circularity is to reduce dependency on these and to reduce these outputs by facilitating this circular process whereby materials, elements, components and parts re-enter the system at the lowest level of loss, so as close as possible to building use and function. So actually in this scenario, recycling is the lowest level of circularity, the least advanced. Circularity in construction is an emerging field with growing research, and the application and assessment of circularity in particular is complex. There are a diverse range of circularity definitions and diverse indicators being discussed and proposed. An example is Sidini, who has classified over 55 circularity indicators based on 10 criteria. We're also seeing the emergence of a diverse range of methods and tools, from very high-level tools such as the material circularity indicator developed by the Ellen MacArthur Foundation to more specific building circularity indicator tools such as developed by Alba Concepts. One key and core indicator that's very much at the heart of circularity in construction is the aspect of design for disassembly and associated design for adaptation and design for flexibility. The ability to disassemble and adapt is critical to facilitate the recircularization of buildings or their elements, components, parts and materials. So this aspect is fundamental and at the core of circularity. We can begin to consider the challenge and complexity of assessing design for disassembly and measuring it as we start to consider buildings in terms of their hierarchical structure and the difference between technical and functional decomposition. And when we consider the level of definition that one needs to go to from building to element to component to material level, we can see the level of complexity and disaggregation and the data sources that are needed to truly undertake in-depth design for disassembly and also circularity assessments in buildings. The Drive Zero project is based on its own particular definition of an optimal circularity focused on both energy and materials. A circular deep renovation which contributes to a circular built environment based on 100% life cycle renewable energy, with all materials used within the system boundaries part of an infinite technical or biological cycle with lowest quality loss as possible. So circular is much more than just reuse or recycling. It's also trying to reduce the amount of initial and recurring and additional process energy by the circularization itself, and therefore has an emphasis on 100% renewable energy contribution as an optimal circular target with infinite material life cycle and lowest quality loss possible. The Irish demonstration project has focused its circularity emphasis on bio-based materials and the biological cycle. A comprehensive inventory was undertaken of available bio-based materials within Ireland. And from that, a range of proposed alternative bio-based materials have been made for consideration within the 2D facade panel. Importantly, this study highlighted the import dependency for bio-based materials within the Irish construction sector. A range of constructions and material specifications have been proposed, including conventional insulations and bio-based insulations, for assessment within the Drive Zero circularity approach. The circularity assessments for construction undertaken within Drive Zero have focused on two key aspects: design for disassembly and embodied energy, embodied carbon of materials. These have been applied for the 2D wall facade upgrade. In the Irish case, a design for disassembly assessment using that approach was undertaken for a comparative assessment of the two-dimensional modularised wall panel based on conventional insulation materials, both quilt and plastics, and the 2D wall panel based on bio-based alternatives, both of these being compared with a conventional EWI system alternative. The results of that assessment gave overall indicators as follows. For the 2D modularised solutions were scoring at medium circularity, 0.72 for the conventional and 0.75 for the bio-based, and the significantly lower score attributed to the EWI system, in part due to the material specification, but predominantly due to the chemical bonding and inability to disassemble without damage to materials within that system. However, looking at the material indicator, which was a small subcomponent of the design for disassembly indicators, of which there were three: connections, accessibility, zoning, and perimeter framing, it indicates that the bio-based is scoring better in terms of material specification, with the conventional system second and the EWI system scoring the poorest. The circularity assessment for construction undertaken within Drive Zero, which focused on DFD and embodied energy carbon, has led to some learnings and critical observations and comments. Firstly, in relation to the scope of indicators used, we see that only two core indicators were used for the circularity assessment, which is significantly limited in comparison to other methods. The DFD assessment only used 4 DFD criterion, whereas other methods apply a more sophisticated range of DFD criterion. Importantly, the indicators scoring were not weighted or adjusted by proportion of material. So elements that may have been low mass and of lower significance within the construction compared to elements of a higher volume or significance scored, their weighting was similar and their impact in the overall scoring was not adjusted by proportion to weighting, which may have a significant impact on scoring and comparisons. Thirdly, the method was assessed on the construction as a whole and not taking building hierarchy into account. Lastly, the material scoring of the method, which was a sole indicator in proportion to 4 design for disassembly indicators, meant that it had a disproportionate weighting. This had a significant impact considering bio-based materials, which are considered a key and an alternative to the technical cycle. They were in the Irish demonstration case seen to be not weighted proportionally or favorably, with no significant difference in the overall circularity score between the bio-based materials and the conventional insulation materials. There were also important observations and comments arising from the material aspect of the embodied energy, embodied carbon assessment and cross comparison of constructions. Importantly, embodied energy and embodied carbon data sources being utilised from the UK ICE database were not always relevant or applicable to the constructions or the geographic context. Importantly, the bio-based material data within the ICE database was significantly limited, and in cases there was no data for equivalent materials, and therefore dependency on the ICE database would distort results. Lastly, the material assessment was based on the initial embodied energy, embodied carbon of the materials, and the circularity, reuse, remanufacture, reprocess energy assessments were excluded. So in that sense, the assessment was non-holistic. Finally, I'd like to take time to make some commentary and discussion on the issue of circularity in buildings and construction arising out of the Drive Zero project. Firstly is to acknowledge and identify that the issue of circularity and construction in buildings is an emerging field with a significant amount of current research being undertaken, and the thinking, methods and approaches are all in development. Secondly is to acknowledge that there are a diversity of interpretations and definitions of what circularity is. In many cases, the definitions are overlapping with other indicators, particularly environmental indicators. I would argue for a more purist perspective on what circularity is, in that it should be considered circularization of the linear supply chain, and its assessment should focus on what facilitates the circularization process, and that social impacts and environmental impacts or benefits are a result of the circular process and not the object of assessment of circularity. It's important to realize that circularity is not one thing, but has a diverse range of indicators. Therefore, a multi-criterion approach needs to be made in relation to assessing circularity, and that criterion will be based on the extent of the circularity definition. However, taking what I'm proposing as a purist circularity perspective, let's discuss some key indicators to give an indication of the range of criterion that would need to be assessed and considered in a holistic circularity assessment of building or construction. So let's start with a discussion about the raw materials and resources. So we're talking about both energy and physical materials. A key indicator is the amount of those materials being used, or mass, into the supply chain. Another indicator is whether they're from virgin or renewable resources, and particularly if they are from resources of depletion or toxicity, especially toxicity, because any toxic materials that go through this system or are introduced during it will have significant impacts on impeding this recircularization stages, and also have impacts on the type of waste output. So we can see even on a material level, there are a range of key sub-indicators. Then we take the process itself, and in that process there is material and energy inputs, which also need to be considered. And again, the same comments made here in relation to resources also apply in the process phase. Then at the heart of this circularity indicator is design for disassembly and design for adaptability and flexibility at higher levels in the building. This is the key facilitator that enables the disaggregation of parts, elements, components, or materials into what I call the rephase, the recircularization phases. So it's an essential and core indicator. Within that, each of these recircularization phases have their own indicators because they introduce often other materials and they introduce other processes and energy intensities. In addition to that, we can see that lifespan and durability are very important indicators, because durability and lifespan may mean that something does not have to enter the recircularization phase due to reaching end of life or not being durable for purpose. And also it means that components, elements, and materials that are re-entering the recircularization phase can do so without breakdown, or can do so multiple times. So based on this simple discussion, we can now see that circularity is actually exceptionally complex, and to measure circularity holistically requires a multiple range of indicators and criterion to be assessed. So we should now see, given the diverse range of criterion, that assessing circularity is complex and that there is a diverse range of data needs to undertake holistic circularity assessment. We can clearly see that DFA, DFF, and DFD are at the heart of circularity assessment methods for construction and buildings because they're the key enabler to facilitate the recircularization process. Given the diversity of interpretations and definitions and the diversity of criterion and indicators, and that it's still very much an emerging field, it's easy to understand why there are a diversity of assessment frameworks, methods, and tools. I think it's fair to say that at this stage, circularity assessment is probably more of a research focus than being applicable in design practice, given the complexity involved. However, emerging out of these circularity studies may come better tools, but should come clear design principles and guidance, which is very much needed. And to highlight that, arising out of our Drive Zero research, we are introducing circularity as a component within our MSc in energy efficiency design, both within modules and within studio projects. This is an example of student work looking at circularity assessments, and here we see a student undertaking a hierarchical breakdown of components and elements right down to their base materials. And here we see another student proposing an assembly sequence and designing a modularized facade. So in summary and in conclusion, I'd like to make some comments about the learnings we're deriving from Drive Zero. While we're undertaking a deep retrofit, the main learnings are in terms of modularization and circularity. And while it's clear there are circularity benefits to modularized solutions, but they do need to be enhanced, the issue of increased cost compared with increased speed and also the additional utility that a modularized solution may be able to provide beyond just upgrading the thermal envelope is an important aspect, and it's a key focus of our study. In relation to circularity, we're seeing that it's an emerging field. There is complexity, there's significant diversity, including in terms of assessments. But the key design principles are emerging, and that is the centrality of design for disassembly, adaptation and flexibility, and also that material specification is really important. And it's become quite clear from this work and the work we're doing in the university that we are currently not designing or building circular. So we have quite a challenge ahead of us. So thank you for your time and for the opportunity to make this presentation. If you need further information on the Drive Zero project, you can go to their web portal here. And if you need to contact me, you can use my academic email address here. Thank you very much for your time.